Hi guys, welcome back to another Mu Alpha Data IM1 Math Tutoring to Go video. Today we're going to be talking about solving systems of equations by elimination this time. We previously talked about solving systems of equations by substitution, but this is a new method, so let's get into it. Okay, so before we get into examples, I'm just going to talk a little bit about what elimination is. In previous episodes, we have discussed substitution and how you can use that to solve for systems of equations, but elimination is another method that will give you the same answer, but might be a little bit easier in some scenarios. So elimination can be used in systems of equations where there are two different variables. What you typically do is you manipulate the equations so that you can easily add or subtract to eliminate one of your variables so that you're left with a single variable equation that is going to be easier to solve and is going to allow you to solve for both of your variables independently. So let's get into some examples. Okay, so we're just going to start off with a fairly easy example that'll kind of introduce you to the idea of elimination. So with substitution, we would typically start by isolating one of our variables and then substituting that into the other equation. But with elimination, we are going to be adding our two equations together. So how we would do that, our main goal with elimination is to get rid of one of our variables. So we can see here that we just have one positive y and one negative y. So if we were to add these two equations together, those two y's are going to cancel out. So this is going to be a fairly easy example of elimination where these are already set up how we like them and they're already going to cancel out easily. So y plus negative y is just going to be 0, so that's just going to leave us with 5x equals 10. And then we can divide that by 5, and then we're going to get that x equals 2. And then if we were to plug 2 back into our original equation, we can pick either one. Let's say the first one. I could say 2 times 2 plus y equals 5. And then I would get that this is 4, and I would subtract 4 from both sides. So I get y equals 1. So that's a pretty simple example. I have x equals 2 and y equals 1, where in our original equations, both of our variables from each equation have the same coefficient. But there are some cases of elimination where it might not be so easy, so let's get into some harder examples. Okay, so here is another example where we're going to be trying to solve by elimination. Now, looking at this equation, both of these equations, you might notice that none of the variables have the same coefficient. And that means that we can't simply jump to adding, because if we were to do that, then that wouldn't cancel out any of our variables. So what we must do in order to solve by elimination is to multiply each of these equations by something so that both of our coefficients for one of our variables are the same, except with different signs, so that when they're added together, they cancel out. So for my purposes, I'm just going to choose to do this with y, but you could also do this with x. It would work either way. So what I'm going to do is figure out what numbers I can multiply both of my coefficients by in order to make them the same number. So looking at this, I could say that they could both be multiplied by a number to equal 12 easily. So what I'm going to do is I'm going to multiply this top equation by 3, and I'm going to multiply this equation by negative 2. And the reason I'm multiplying it by negative 2 is because if I were to add these together and they're both 12, that would give me 24, not 0. So I need to make this a negative number so that when they're added together, my coefficients cancel out. Okay, so then I would solve for these, and this is going to give me 15x plus 12y equals 66. Oh, ignore that. 66. And then this is going to give me negative 14x minus 12y equals negative 64. Okay, so now I can see that both of my y variables share the same coefficient, but with different signs. And that's what you're always looking for when you're doing an elimination problem. So now I can add these two equations together. So I can say 15 plus negative 14x is just going to give me x. And then I have 12y plus negative 12y, which is just going to give me 0. So plus 0. And then I have 66 plus negative 64. And again, this is just going to be the same as saying minus 64. So that's going to give me 2. So now I know that x equals 2. And same as I did with the last one, I can just plug that into either of my equations. I'll do my first one, and I can solve for y. So let's say 5 times 2 plus 4y equals 22. I know 5 times 2 equals 10, so I will just subtract 10 from both sides. So that's going to give me 4y equals 12. And then I can divide both sides by 4 to isolate y. That's going to give me y equals 3. So my x value is 2 and my y value is 3. So that's a little bit more of a difficult example where I am solving by elimination. Okay, so those are the basics of solving for systems of equations using elimination. Thank you guys so much for watching. If you have any questions, you can reach out to any of your Mualpha Data officers. And please continue to watch our Math Tutoring to Go videos. We have new uploads every week. Thank you for watching.